Okay, so let's talk about how we find the radius and interval of convergence. So the first thing you're going to do is apply either the ratio or the root test to your power series. Most often it's going to be the ratio test and not the root test. Okay, and once you get your limit, what you want to do is set that limit to be less than 1. And the reason for that is that the ratio or root test will converge absolutely if the value of that limit is less than 1. Okay, so there are 3 possible radii we can get from this. So the first is that your radius is equal to 0. The second is that your radius is a finite number. And by finite, I mean non-zero, since we already covered the 0 case here, and less than infinity. And then the third case would be that your radius is infinite. And then a radius can't be negative since we're measuring this as a positive distance. So it's either 0 or positive. Okay, so these are the 3 possibilities. And let's go into the details for each of these. So if your radius is 0, that means that your power series is going to converge only for your center. So that means it's only going to converge for x equal to c. So just one single point is the only place it'll converge for. And this is going to happen when you take this limit on your ratio or root test, and that limit, L, is going to infinity. Okay, so if it's going to infinity, the only way you're going to get that to converge is just only at the center. And we'll look at an example of that. Okay. If your R is a finite number, a non-zero finite number, then your power series is going to converge for an interval. Okay, so for a series of x values. Okay, that's really the interesting case. So these 2 outside cases are not very interesting, but this middle case is the one that is pretty interesting. This is going to happen when you find that limit on the ratio or root test, and that limit is equal to some sort of constant times that piece that has your center, so times the absolute value of x minus c. And you're going to set that to be less than 1. Okay? So that process of finding the limit on the ratio or root test results in some sort of finite number times the absolute value of x minus c that you then set less than 1, and then you solve for x. Okay? So typically your radius ends up being 1 divided by whatever that constant is. Okay? There's a few cases where that doesn't happen, where it's a little more complicated than that, but most of the time it's going to be 1 divided by that constant. And then the last case is that R is infinite, and in that case your power series converges for all real numbers. Okay, and you'll run into this case when your limit L is equal to 0. Okay, and that's going to be the case because if your limit is 0, that's always going to be less than 1, right? And so no matter what x value you plug in, if your limit is always 0, it's still always going to be less than 1, so it's always going to converge. So we'll get convergence for all real numbers. All right, once you've found the radius, what you want to do is break it out of the inequality, break it out of the absolute value into an inequality. So like this example we looked at earlier, we had this radius of convergence as being the absolute value of x less than 1. So we broke it out of the absolute value and into this inequality of -1 less than x less than 1. So we would call this -1 and this +1 the endpoints of our interval. Okay, so these are both x values, and what we would do next is we would take these x values and we're going to plug them back into our original series. Okay, so you would take those endpoints and come back up here and plug them in. And what that does is now your series no longer has an x in it. Okay, so you're going to create 2 new series that no longer have an x in them. And you're going to test those series to see if they converge or diverge. Okay, so if that new series with that endpoint plugged in converges, then you're going to include that endpoint in your interval, and you're going to use a square bracket to do that. If your new series with the endpoint diverges, then that endpoint is excluded, and you're going to use a rounded bracket to not include it in your interval. Okay. Now the one point about this step is that you cannot use the ratio or root test to do this. Okay, so you have to use a different test than what you used up here. Okay. Then the last step is just to take these two parts here and write your interval. Okay, so it's just kind of a summary of what you've learned in the last two steps. Okay, so I've given you this acronym REI. We are an outdoor school. REI is an outdoor company, so hopefully that kind of helps you to remember that. Then I've got a couple of tips here for you. So the center is always at x equals c. The power series will always converge for at least one point, the center. Okay, so always at least there's one value you're going to get convergence. Again, don't use the same test for the endpoint that you used to find the radius. So don't use that ratio or root test again. And then the series, your power series, will converge for any value of x inside your interval. And then for any value of x outside your interval, that power series diverges. Okay. So come back in the next video and we'll start looking at some examples of this.